Hello, Namaste, Sat Sri Akal. Welcome to the webinar today. I, Varsha Jaiswal, co-organizer and WTM ambassador of GDG WTM Jalandhar, is here to take you through the webinar on WebAssembly. Before fostering the session, I would like to drive your attention on the upcoming event, which is International Women's Day 2020. It takes an immense pleasure to share that for the first time, 35 WTM communities from all across the country united to celebrate IWD India 2020. Register yourself at gwo.gle/WTM India-IWD20. We share daily updates on the Twitter handle of WTM India and WTM Jalandhar. Without further ado, I would like to introduce the speaker of the day, the person with a passion of sharing his knowledge, whose love for traveling led him to do summer internships in many countries. Let's give a warm welcome to Pramod Mahato. Over to you, Pramod.
Today we'll be talking about WebAssembly and what the heck is it. So before jumping over to WebAssembly, I would like to tell you the brief history of JavaScript. JavaScript was developed in 1995 for making more interactive and dynamic websites. And to run it, we needed to add it with the HTML codes. And the execution environment was provided by the browsers, and it was only runnable on web browsers. And at this time, JavaScript could only be used for client-side scripting. Then a guy named Randall developed a runtime environment for JavaScript and named it Node.js. And by using Node.js, now JavaScript could be compiled without browsers too. And then it also became server-side scripting language. And then as times changed, we started seeing more complicated applications which needs more computing power or more processing power. But JavaScript is single-threaded, which makes its performance slow when it comes to dealing with heavy applications, because other tasks has to stay in queue until the previous task gets executed. And it cannot access the OS level features. So there were few limitations to JavaScript, which made it harder to develop and run heavy applications on it. And that is where WebAssembly came into the picture and took the capabilities of web-based applications to the next level. Now let me tell you how. So according to the official websites of WebAssembly, that is webassembly.org, they define WebAssembly as it is a binary instruction format for a stack-based virtual machine. And it was designed as a portable target for compilation of high-level languages like C, C++, Rust, so that these can be used to deploy clients for web applications. So what WebAssembly actually does is it takes the C, C++, C hash, or Rust, these code bases, they compile it into a WASM file. It's called a WASM.js file. And then that WASM file is being integrated with JS, CSS, and HTML to produce a rendered output on your website. So by using WebAssembly, now we can also integrate C or C++ code to our web pages. Pretty cool, huh? So in simple terms, WebAssembly is a language for web technologies, and it is compiled from other languages like C, C++, Java, Rust, Go, and it offers maximized and reliable performance. Because we all know when it boils down to space complexity and time complexity, C, C++, these languages can do wonders. So and yeah, please do not confuse WebAssembly as a replacement of JavaScript. But why do we need it? Browsers can only understand HTML, CSS, and JavaScript. Those are the skeleton of any web pages. And you simply cannot get that low level with JavaScript or any other framework of JavaScript. And WebAssembly complements JavaScript. It gives some extra features to the web pages. It boosts the capabilities of any web page. It doesn't mean that it is a replacement of JavaScript. It just adds some extra features. It just boosts up the capabilities of our web technologies. And it gives us access to a set of low-level building blocks that can be used to construct something beyond the capabilities of web browser. Few things which weren't possible in web browsers. Suppose we play some games Suppose we used to play GTA, we used to play NFS, and we used to install those softwares in our systems, and we couldn't even imagine that we can play such high-end graphic games, such games with high level of requirements in our web browsers. That wasn't possible before the existence of WebAssembly. So WebAssembly has pushed the limits of web technologies a lot, and I'll be also showing you a few examples in next few minutes. So what is WebAssembly good for? WebAssembly is good for high performance codecs, video games, in media editing. As I gave you example of GT or NFS, or be it any game, you can play it in browsers right now. That's possible only by using WebAssembly. Talking about media editing, suppose you have softwares like Adobe Photoshop or be it Adobe XD. So these are media editing applications, and they have lots of features. And when it comes to web based platforms, it just gets complicated. So by using WebAssembly, we can execute, and we can execute these kind of platforms on web too. And WebAssembly is also good because there are lots of open source libraries available on GitHub, which are written in C, in C++, on Rust, or on Golang. There are lots of existing code bases. So before this, suppose I'm developing a website and I want to use algorithm for image compression, and I know that there is a pre-existing library which is written in C or C++, which has very less complexity, which is a very optimized code, but it's written in C or C++. Before this, we couldn't integrate that code into our websites, but now, after the existence of WebAssembly, after WebAssembly came into the picture, now we can even use those code bases, and there are thousands and thousands of code open source projects available on GitHub. Now we can integrate those algorithms, those codes on our websites. Pretty cool, right? So WebAssembly supports lots of languages like Rust, C Hash, Golang, Kotlin, C++, Haskell, and a lot of them. So whichever you are comfortable with, you can just go and start your first WebAssembly project with it. So how WebAssembly actually works, like how to integrate it. You can call the JavaScript can directly call a function which is exported by WebAssembly. If you are familiar with web development, you know how to call a function in JavaScript. So what you have to do in WebAssembly, suppose I am writing a project on WebAssembly by using a language C. What I have to do is I have to export that function in my C file, from my C file, and I have to import that same function in my JavaScript file. In the ES6 of JavaScript, with the ES6 feature, we have something new called module.imports and module.exports. So we'll be using the same thing. We will just export the function from WebAssembly file, from the C file, and we'll import the same. We'll use the same function. We'll just call the function in our JavaScript page, and I'll also show you how. So I'll show you a few websites which are using WebAssembly, and how it has pushed the limits of web-based technologies. There is a website called Air Console. So what they do is, suppose you had an Xbox, and then you went on and you bought a new PlayStation. So it doesn't mean that you have to go and buy new controllers, or you have to buy new stuffs for it. What you can do is you can just go to airconsole.com, and then you can create a room, and you and your partner both can create a room, and now your phones will turn into a controller. So how cool is that? You don't have to buy any more console, no hardware changes and nothing. And this is possible by using WebAssembly. And if you are familiar with UI designing or UX designing, you must have heard about Figma. Figma is like Adobe XD, and it has a lot of features in it. You can create UI layouts, you can create activities, you can design user experience patterns. You can do there are lots of features in it. And before the existence of WebAssembly, these things were really complicated, because by the help of JavaScript only it gets really complicated. So but Figma is live, and Figma is using WebAssembly to back its website. If you have ever been into gaming, you must have heard about Unity. And even if you haven't been if even if you haven't heard about even if you haven't been into gaming stuff, you must have heard about Unity. And there are lots of online games of Unity. So how do they power them? How do they make it available for the users? How do they make it available for the end users so that the users can play it just on your website? It is possible only by using WebAssembly. Yeah, and talking about VLC.js, if you are a web developer, you must have used the HTML5 video tag. And we know that if we use the video tag, we just have limited set of features. Like we have a play button, we have a pause button, and then we have the seek bar, and just the normal facilities which is provided by HTML. And in the same way, if we talk about VLC Media Player, which is available in our desktops, we know that it has a lot of features. And if we go and start developing that kind of features in our website, it will take a lot of work, and it will be very complicated for our JavaScript to handle. So what the VLC team has done, they have used WebAssembly and they have created something called VLC.js, and now we can use VLC.js and integrate VLC.js in our website so that we can provide all the VLC media player features on our web application too. So how cool is that? So many features, and it is only possible because of WebAssembly. Yeah, Google Stadia. This thing is really cool. Do you remember the days when you used to wait so long just to download games? And the Google Stadia came up with an online platform where you can just go and click on the game you want to play, and then you can start playing instantly. Let me show you a video.
Okay, so you're wondering, what exactly is Stadia? We've got you covered. Stadia is an all-new way to enjoy your favorite hit video games, only you don't need an expensive console or PC to play. Stadia streams games directly from Google's data center's device. It's like music or TV shows, but with high-quality video games. To play on your TV, plug in a Chromecast Ultra and set up your Stadia controller using the Stadia app on your phone. Once you're set up, you buy the game you want, then you play it instantly. You don't have to wait for it to download either. Seconds after you press purchase, you'll be streaming your game directly from the internet to your screen. And since it's powered by Google's data centers, your games can run at premium specs, up to 4K resolution and 60 frames per second with high dynamic range colors. But it doesn't stop with your TV. You can bring the same incredible gaming experiences to just about all the screens in your life. Your favorite games on your laptop, desktop, and select tablets and smartphones. Is your roommate interrupting your game to watch a show? Switch over to your laptop and pick up right where you left off. On a trip? Stream games on your smartphone. Anywhere you've got Wi-Fi, you're just a click away from buying the latest titles and instantly playing your games. Which also means you're always a click away from playing with your friends. The Stadia controller connects directly to the Stadia servers to give you lightning-fast response time when playing wirelessly. If you're in love with another controller or a mouse and keyboard, you can use those to play Stadia on your computer. Stadia Pro is our premium subscription. It gives you up to 4K resolution with 5.1 surround sound and free games regularly. The longer you're subscribed to Stadia Pro and the more free games you claim, the larger your collection will be. Now you're an expert in all things Stadia. Coming to all kinds of screens everywhere. For the latest updates on Stadia,
Stadia for you. I still remember the days when I used to download games which was of like 8 GB or 10 GB, and I had to wait for it. I had to wait that when the download will be complete. And then after the download is complete, sometimes what happens is it takes a lot of time to install, and sometimes in the installation just can't happen. It says that there are a few DLL files missing. And there's sometimes when it says that my hardware isn't capable enough to play this game. So go on other days. We can just simply log on to the website. We can simply download the application. And we can play whatever game we want, and your hardware specification doesn't matter anymore. How cool is that? And that is possible only by using WebAssembly. Stadia is powered by WebAssembly, and now we know how cool is WebAssembly, right? So let's go and see. Let's go and start our first WebAssembly project. I'll give you a brief overview. So we can just go over to this website called webassembly.studio. Let's create our first WebAssembly project. So here we have lots of options. So I'll be going with MTC project. We just have to simply click on create. So this is, first of all, on the left navigation bar, you can see that there's a folder called source, and in the source window you can see that we have three files. There's a C file, and then there's the HTML file and JS file. And before the existence of WebAssembly, you must haven't have ever seen this C file. we have seen HTML file, we have seen JS, we have seen CSS, but this C file, this is something new. So let me show you. Let me show you the output. So now, when in the HTML file, we can see that there's just a container, there's just a normal body, but on the rendered output page, we can see that there's a number 42 popping up on our web page. So where is the 42 coming from? In the HTML file, we haven't mentioned 42. Let's go and jump over to our C file. There we go. There's a main function which says return 42. So this 42 is being fetched from a C file. Let's try and make some changes. Int a is equal to 2. Int b is equal to, sorry. Let's return a plus b. So first of all, let's just go and save it. And now let's click on run. Now we can see the output has changed. Now on the HTML page, on the rendered output page, we can see that we are getting 6. And where is this 6? Where is this data coming from? Is it coming from the HTML page or from the JS page? No, it's coming from the C page. How cool is that? Like, before the existence of WebAssembly, it wasn't even possible that we can integrate a C or C++ or Rust or Go, any kind of language. But after WebAssembly came into the picture, now we can integrate C, C++ into our web pages too, and which has boosted up the capabilities of web technologies a lot. So this is how you can just go to GitHub, and there are lots of open source. This was just one example. There are lots of open source libraries now, which are written in C, C++. Now you can go and you can use their code, and you can integrate it with your web page and create a lot of new stuffs. So how cool is that? So with this, I hope you guys learned something new and saw something cool which wasn't possible before the existence of WebAssembly. So thank you.
Wow, thank you, Pramod, for this informative webinar today. I think there are no questions for you. So, guys, if you are facing, like, if you face any questions, like if any issues, you can just tag us on Twitter by tagging GDG Jalandhar. We will try to answer your questions there. Thank you, people, for joining us for this webinar on WebAssembly. To become a member, you may join us at meetup.com/jdg-jalandhar. Till then, bye-bye. Take care. See you at IWD India 2020. Stay safe, stay home. Thank you.